Good morning. Today we'll start with lesson 2 in unit 1. It's about graduation of element properties in the modern periodic table. Graduation of elements properties in the modern periodic table. Last lesson we talk about the type of table that we study, the element properties. In this lesson we'll study the graduation of these properties in the modern periodic table. After the scientist designed the table according to atomic number, they found the properties also graduated in the table. They found that the properties of the element are graduated in the modern periodic table. And they found there are relationship between its properties and the number of electrons in outermost, or the electronic configuration. This means the properties of the element related to the number of electrons in the outermost or its electronic configuration. We will study 3 of these properties. The first one, the atomic size. The volume or atomic size of the element, what happened to its atomic size in the table? What is the period and the group? It increase or decrease or remain as it is. The second property about the electron negativity of the element, electronegativity of the element, and we will study it later. Third property about its metallic and non-metallic property. So we'll study 3 of these properties, and we will study what happened to this property in the table. What happened to the atomic size in period and group? What is happened to the electronegativity? And who is the metal, who is non-metal? What happened to the metallic property in the table and non-metallic property? First, we must know the atomic size. We know that each matter has a volume and has a mass. Volume means the size of the element, but the atom is very, very small, and we can see by our eye. So we see the element or the atom by electronic microscope, some type of microscope called electronic microscope, to see the very small size of the atom. And the size measured by the radius. We know the atom shape of the atom like oval or like circle. Yeah, it's related more to oval, not a circle. This is the nucleus of any atom, and this is the energy level. The radius of any atom, starting from the center of the nucleus to the last electron in the outermost energy level. This is called the atomic radius. So the atomic radius of each atom, we measure from the center of the nucleus of the atom to the last electron in the outermost energy level. This is the distance called atomic radius of the atom. So the distance measured by meter like any distance, but we use a very small unit of the meter called the picometer. Picometer. So the atomic radius, we measure by it the atomic size of the atom by unit called the picometer because it's distance, and we measure it from the center of the nucleus to the last electron in the outermost energy level. But today, this was in the past. Today they use some type of ray and electronic microscope to measure accurate atomic radius. But in the past, they used from the center of the atom to the last electron in the outermost. And picometer meaning part of million part of meter. Part of million part of meter. It's mean 2 million times each other. So picometer is abbreviation for part of million part of meter. This is mean 2 million times each other because it's very small. So the picometer equal 1 times 10 power minus 12 of the meter. So it's very, very small unit of the meter. 10 power minus 12. So we know how to measure the atomic radius. What is the unit to measure? Picometer. Very, very small unit of the meter equal 1 times 10 power minus 12 of the meter. What happened to the atomic size in the period of this is part of the modern periodic table. This is part of modern periodic table. As we see, the below circle, this is the size of the elements. As we see in the period, in the same period, the atomic size or atomic volume or atomic radius decrease. The lithium has larger size than fluoride. Lithium has a larger size than thorium, than 4. So in the same period, the atomic size decreases from left to right. About group, what happened to the size as we see? In the same group, the atomic size increase to the size in period opposite to in group. The atomic size in period decrease from the left to the right and increase in the same group from up to down. Like lithium, small size than sodium, potassium larger than sodium, rubidium and cesium larger than rubidium. So the atomic size increase in the same group, but decrease in the same period. Why? Why this happens? In the same period, atomic size decrease. We study in the last lesson, we know the number of period from the number of energy level. Number of energy level, we know it, the number of period. Lithium, we distribute the electron in lithium and fluorine and compare between them. Lithium has 3 atomic numbers, so it has energy level. K has 2, L has 1 electron because it's 3 atomic numbers. What about fluorine? Fluorine has 9 atomic numbers. 9 atomic numbers. We can distribute the electron in the fluorine has also 2 energy level because in the same period the number of energy level equal. So all period number 2 has 2 energy levels. So lithium and fluorine have the same number of energy level K and F. But lithium has 2 electrons and 1 in L, but fluorine has 2 electrons in K and 7 electrons in L because all the sum of atomic number of fluorine is 9. They all have the same number of energy level, but what is the difference? The number of electrons in the outermost. Lithium has 1 electron in outermost, but fluorine has 7 electrons in the outermost. The number of electrons outermost, how it's affect on the size? Yes, it very affect on the atomic size. How? We studied in grade 7 that the nucleus has positive protons, so the charge of the nucleus is a positive charge, and the electron in the outermost has negative charge. Negative charge. So between the positive proton in the nucleus and the electron in the outermost, attraction force. So between the positive charge of the nucleus and the negative electron charge, attraction force. Each atom, there is attraction force between its nucleus and the outermost electron. This attraction force affected by the number of electrons in the outermost energy. How? If the number of electrons increase in the outermost, that means the attraction force increase. So the lithium has 1 electron only in outermost, so the attraction force is small. But fluorine has 7 electrons in the outermost, so the attraction force between the nucleus of fluorine and the 7 electron outermost larger. So attraction force in fluorine atom larger between the nucleus and the outermost, so the attraction force mean is pulling. This is the attraction force in the nucleus pulling the electron toward it. So attraction force increase. So the number of electrons increase. So the number of electrons outermost affect on size. Because there is attraction force between the positive proton and negative electron. The number of electrons in the outermost increase. So the attraction force increase because the nucleus pulling electron toward itself more, so the size increase. So when the number of electrons increase in the outermost, attraction force increase and the size decrease. So the chlorine has small size than this. This is what happens to all the atomic size in the bed, same bed. The attraction force in the nucleus and the electron in helium larger than lithium. So it's falling toward it, so the size decrease, and so on. So the lithium has 1 electron and outermost. Chlorine has 7, so the attraction force between nucleus and the electron in chlorine larger, and it's falling towards the nucleus, so its size decrease. This is what happened to the size entry. The atomic size decrease. Why? Because increase the atomic number in the same period, so the attraction force increase between the positive proton in the nucleus and negative electron outermost increase. So the as atomic number increase, the attraction force the positive proton in the nucleus electron increase, so the size decrease. But what about that group? Or it's increase or decrease? We see it increase in the same group. So the atomic size increase in the period because attraction force increase. But in the group, it's about attraction force also? No. It's about something, another thing than the attraction force. We will study it. In the same group, we know that the group number, we know it from number of electrons in outermost. So the number of electrons outermost in the same group are the same. Have lithium also have 2 energy level, K and L, have 1 electron outermost. Sodium has 11 atomic number. So had distributed. K has 2 electrons. L has 8 electrons. M has 1 electron. So the sum of them are 11. So the sodium has 11 atomic number. Lithium has 3 atomic number. They are different in number of energy level. We know that same group, the number of energy level different, but same in the number of outermost electrons. So in the same group, the number of outermost electrons are the same, but the number of energy levels are different. How the number of energy level affect on the size of the atom or the element? As we see, the lithium between the nucleus and the outermost energy level, attraction force, and also between the lithium nucleus and the electron outermost, there is attraction force. When the distance increase between the nucleus and the energy level increase, the distance increases, the force are the same or become weaker? It's become weaker. So the force become weak if the distance increase. Distance increase meaning the number of energy level increase. So the sodium has 3 energy levels. So the distance between the electron outermost and nucleus increase. So the force decrease and the size increase. What happened? This is in the same group. So in the same group, the distance between the number of energy level increase as we move down. First, lithium second period has 2 energy levels. Sodium in third period has 3 energy levels. Potassium in fourth period has 4 energy levels. So as we're moving down, the number of energy level increase. So the distance between the nucleus and the electron outermost increase. So the size decrease because the force will be bigger. What happened in the same? Why the atomic size increase in the same group? Because the number of energy level increase as the number of atomic number increase. So atomic number increase in the same group, so the number of energy level is divided by 15 increase. And this is why the size of the atom increase as we move down in the same group. So we can revise what happened to the atomic size. Atomic size means the atomic radius, and we measure it by unit called ecometer. Ecometer is a part of million parts of the meter. 10 times over 1 times 10 over minus 12 of the meter. The atomic size. Graduation difference in period and group. The atomic size decrease in the same period and increase in the same group from up to down. The atomic number increase in the same period. The number of electrons outermost increase as we move from left to right. The attraction force increase between the nucleus and electron, so the size decrease. In the same curve, the atomic number increase as we move down, and the number of energy level increase, so the distance increase between the nucleus and the electron outermost, force decrease, and the size will be increased. This is what happened to the atomic size in period and group. When we want to describe this relationship between the size and the atomic number in graph, we describe the relation between the two factors by graph to know what happened. We are directly or inversely proportional to each other. When we compare two factors, the x-axis and y-axis, we put one on x-axis and the other on y-axis. X-axis and this is y-axis. When we're putting the atomic number in x-axis and size in y-axis and compare between them by number as we move in the same period. When the one factor increase, we see that in the period the atomic number increase but the size decrease. So one factor increase, the other factor decrease, so it's called inversely proportional. When one factor increase, the other factor decrease, they are opposite to each other, so we call between them inversely proportional. But when the two factors increase with each other or decrease with each other, we call it directly proportional. So in the same period, we study the atomic size and number are opposite to each other. When the atomic number increase, the size decrease. One factor increase, other decrease, so it's inversely proportional. So all between atomic size and number in period inversely proportional to each other. And we draw it as direct graph and a graph moving down. But how about the number atomic number size in group? In group, we see that the atomic number increase and also the atomic size increase. So the two factors are the same, so it's called directly proportional. So between the size and the atomic number in group, between them directly proportional, and we draw it like this graph, as the graph is upward. So from we study in the atomic size, we see that the element in group 1A has the largest size in all the modern fields. So the group number 1A has the largest element size in all the modern groups. Cesium has the largest size atomic size in all the fields. and he putting in bottom left of the table. Cesium has the who has the largest atomic size element? Cesium. But the fluorine has the atomic number in the period decrease and increase in group, so the fluorine has the smallest atomic size. So when we ask what is the group that has the largest atomic size, it's group 1A. What is the main element that has the largest atomic size? Tritium. What is the main element that has the smallest atomic size? Fluorine. And we ask and give these one, we see the fluorine smallest size in the modern periodic table because the period in size decrease and in group size increase. Cesium has the largest element size. Fluorine has the smallest element size in all the modern periodic. From the atomic size property, we can imagine the relationship between the size of two elements. So we ask me, we have this is element, carbon, fluorine, oxygen, and nitrogen. What happened to the atomic size? What happened to atomic size or order the atomic size as symbol? Symbol means the smallest to the largest. 6, 7, 8, 9. As we see, they are in the same period. All these elements are 6, 7, 8, 9. So all these elements in the same period. So in the same period, we studied the atomic size, big decrease. Big decrease as we're moving from left to right. So when we order the atomic size ascending from the smallest, so the fluorine has smallest, oxygen bigger, and nitrogen bigger more, and carbon are the biggest in this arrangement. So ascending from atomic size, this element, we start from the biggest atomic number, fluorine. Fluorine has smallest, and then oxygen smaller than nitrogen. Nitrogen smallest atomic size. And so from the knowing the atomic number and knowing this element in single group period, we can imagine what happened to the atomic size, increase or decrease. This is about atomic size. In this whole chemical revision, we after putting the element in modern periodic table, graduated according to atomic number, they found that also properties graduated, and they found the relationship between the properties and the number of electron outer mole. From this properties, we will study three. The atomic size, what happened in the table, what is the graduation of the atomic size, increase or decrease in the group, electronegativity, metallic and non-metallic products. We take the first one, atomic size, size the main volume or atomic radius. We measure from the center of the nucleus to the outermost electron, outermost energy level. Its distance, we measure it by meter, but smallest unit of the meter, meter. It's part of million part of meter. It's equal 1 times 10 over minus 12 of meter. And the atomic number increased in the same period, but the atomic size decreased. The atomic number increased in the same group, and the atomic size decreased because in the same period, attraction force between nucleus and electron increased because the nucleus bonding the electron towards the nucleus, so the size decreased. In the same group, the atomic number increased, the number of energy level increased, so the attraction force decreased, and the size increased also. Between the atomic number and the size in the same period, inversely proportional because one factor increase, other decrease. The same group, the two factors increase with each other, so it's directly proportional. And we draw like that. This is inversely, this is directly. Inversely moving down, directly moving upward. Fluorine has the smallest atomic size in all the magnetic periodic table, and it's the upright position. Cesium has the largest atomic size in all the modern periodic table, and in the bottom left of the table, group 1A has the largest atomic size in all modern periodic table. That's for today. Thank you. The next session about electronegativity.